System Practice Homework 6.2. Question 1. For definition, find the Fourier transform of the signal ft in the figures. Let's start with the first one. Basically, it's just calculate the Fourier transform. So based on definition, f omega is integral from negative infinite to infinite ft e to j omega t dt. And we can see the ft is e2 minus at, so we can write down e2 minus at e minus j omega t dt. We get calculate this integral. So also 0 to t, so we can just simply write it like this: e2 minus a plus j omega t dt. So integral minus 1 and 1 e 2 minus a plus j omega. Okay, then we can calculate the integral of this expression, which is a plus j omega 1 minus e to a j omega capital T. Okay, this is the first one. And for second 1b, this the only difference is just the ft from the e to minus at to e to at. So let's just directly write e to at e minus j omega t dt. And of course there is 0, there is to capital T, and then we can just a minus j omega 1 e and a minus j omega t 0 to t. And so we can directly get to minus j omega, and we just put the capital T, replace the small t, minus 1. So this is the answer of the second one. And next question, 2a. Actually, ft, this is piecewise function, and this domain here. So we just basically do the same, except minus 2 ones ft e to j minus j omega t dt, and this two part 0 to 1 for e to j omega t dt, and plus 1 to 2 to e to j omega t dt. And still same, minus j omega for e to minus j omega t 0 to 1, and plus minus g omega to e to minus j omega t 1 to 2. And we can calculate for the first one, 1 to 0 t, so it's j omega minus 4 minus e to j omega. And the second one is, we can just put this outside, so it's j omega 2 times e to j omega minus 2e minus j omega. So if we combine these two, oh, here is 4 times. So if we add them together, it's 4. And then 2e to 2j omega plus minus 2e to j omega. So this is the answer of the 2a, question 2a. And for the last question, we still do the same. 2b, we plot tau minus tau 0. This is 1. Let's do the Fourier transform. Minus negative to infinite ft e to minus j omega t dt. And this includes 2 piecewise, so it's full tau minus tau 0 to 0 to negative 1 over tau times e to j omega t dt plus 0 to tau and 1 over tau times e minus j omega t dt. And do some simplification first. Minus tau is just a constant here, so we can get rid of it here, and then here is t, so it's t times e to j omega t dt, and plus 1 over tau, integral from 0 to tau, and te times j omega t dt. And next, for the integral of this part, we need some help from the table. Let's check. Actually, it's this one. So we can directly use it. Let's write down first. It's integral x times e to ax dx times equals to e to ax over a squared times ax minus 1. Then we comparing these two parts, we can get we just set a equals to minus j omega, x equals t, right? So we can get for the first part here is tau 0 t times e to j omega t dt. We can directly get this part, then minus j omega square, and the denominator part is e minus j omega t, and then it's minus j omega t minus 1. And the second part, and of course, because we need to do this calculation, right? Because we still have t. And then the next part is 1 over tau t times e to minus j omega t dt. So it's tau square. And then all is actually the same. It's just the top and the bottom limit is different. Minus 1, so here is 0 to tau. So after some calculation, we can evaluate the answer is equal to 2 over tau omega square times cosine omega tau plus omega tau times sine omega tau minus 1. That is the final answer. Thank you.